Welcome back, guys. Today and tomorrow we're going to go over just some review stuff to build a good foundation before we move on to any new material in the actual physics course. The first thing that we're going to do is just review unit analysis, dimensional analysis, so that we are very comfortable with using units, figuring out what the correct units are, and converting units. That's not something that we want to be struggling with during the AP test, and it is very important to always be writing units in your calculations. So we'll start with that. Tomorrow we'll talk a little bit about trig and vectors, stuff that you guys learned in pre-calc or will learn in pre-calc, and you probably talked a little bit about in Algebra 2. That's the main mathematics that we use in the physics class. So we want to be really comfortable with it before we start talking about any complex systems. So we'll get a quick review of those things today and tomorrow, and that should help us build that strong foundation. You'll see here the first page in my OneNote under the section for Chapter 1 is one of the first pages in your book that gives you a lot of conversion factors, prefixes, and simple formulas that we need to know. So this is a good reference for you to have. In the actual AP test, there are only a few conversion factors that you need to have memorized, and only a few formulas that you need to have memorized. So it is okay for you to use these references. Things that you need to know for sure are the conversion between like meters and kilometers, or the conversion between a meter and a centimeter or a millimeter, things like that. And really you need to know these prefixes, and we'll talk more about formulas as we go on, but you do need to know basic geometric formulas. All right. Hopefully you guys took some time to read the section listed on my calendar before you're watching this video. If not, pause the video, read the section, and then come back and we'll go over it. One thing to keep in mind is all of these units that we're talking about, a meter, a gram, a kilogram, they're all human constructs. They're things that humans have decided to standardize to make communication between people easier. And here's an example. This is a mass that is, kept in a secure location that other people can compare to make sure that they know exactly how much matter is inside a kilogram. The same thing with a meter. But the important thing to remember is that these measurements they're not like universal numbers that came out of nature magically. We just sort of standardized on a set of units so that it was easier to talk to people. Let's just look a little bit closer at example 1 from your book. There's 3 different types of unit conversion that you want to be really good at, and I'm going to show you an example of each of those 3. The first one is just straight dimensional analysis, one unit to another unit. So in this case, we're going from meters to feet. And the first thing that we're going to do is we're going to write out our dimensional analysis. So we're going to have 979.0 meters. Now you're going to notice that your book follows sig figs very strictly. There's a note on my website about sig figs in the AP test. You'll notice that I don't follow sig figs very strictly. You won't be graded on sig figs unless you make a very erroneous or a very large mistake. So read that note on my website in case you have a question about sig figs and should you be rounding or not, that kind of thing. Okay, so first thing we want to do is we want to set up a blank conversion factor, and we want to convert to feet. So feet would be on top, and we want to cancel out or divide to 1 the meters. So these are going to divide to 1. Now we need the conversion factor, a foot. How many feet are in a meter, or how many meters are in a foot? We can go to this conversion factor chart here, and we can find that there's 1 foot in every 0.3048 meters. We're not going to round conversion factors ever. Um, 3048. Sorry, it would be very small. And so now we've got that set up properly. We can use a calculator to determine the answer. So 979 divided by 0.3048. And that's going to be our answer. Now, again, like I said, we can use sig figs, or we can just use intelligent rounding. In this case, I'm just going to round to 2 decimal places and not worry about sig figs. So we're going to have 3,211.94. And the units are going to be feet. Okay, so this is just straight unit conversion. We went from 1 unit to another unit. There we go. You want to be on the lookout on the AP test for when they give you units in a form that are not compatible. So they might give you a bunch of givens and they're all in different units, and we need to be converting them. So this is a skill you will need on the test. And like I said, we don't want to be fumbling around with this. We want to give ourselves time to think about the more complicated aspects of the problem. So we want to get real good at this. All right, example 2 is a second type of unit conversion where we have a compound unit and we need to convert. So in this case, we want to go from miles per hour to meters per second. And this is a very common conversion for us here in the United States. We're used to talking about in miles per hour, but in physics, we need to be in meters per second. So this is a very common conversion for us. We're going to set it up the same way. We're going to write 65 miles per hour times, and then we're going to set up our unit conversion. We need to be able to convert from miles to meters. So we're going to put meters on top, and I'm just going to write M for meters. And we need miles on the bottom to cancel out miles. So we're going to convert each unit 1 at a time. So that's going to be 1, and then we need to change from hours to seconds. So in this case, we're going to put hours up here at the top and seconds down here at the bottom. We'll go back to our conversion chart for meters and miles. So unfortunately here, we're given 1 kilometer is equal to 0.6214 miles, and we're going to have to work with that if we don't know anything else. Or we could use 1 mile is 1.609 kilometers. And actually, let's go with this first one here. That'll be a little bit easier. So we'll set this up. So that's 1.069 kilometers. .609, right? Yeah, 609. Now we didn't want kilometers, we wanted meters, but we do know that the kilometer or the kilo prefix means 1,000. So we know that 1 mile is equal to, if we move this 3 places, 1,609 meters. So that's what we're going to be using. So we're going to have 1,609 meters for 1 mile. Now, we do want to know how many seconds are in an hour. That's going to be important for us. There are 60 minutes in an hour and 60 seconds in every minute. So for 1 hour, there's going to be 60 squared seconds. and we can type this all into our calculator. We can really quickly make sure we got all the units lined up properly. Miles is going to divide with miles, and hours is going to divide with hours, and we're left with meters per second, which is what we wanted, so that works out great. Use our calculator for this. So we're going to have 65 times 1609 divided by 60 squared. And that gives us about 29.05 meters per second. So there we go. So that's an example of converting compound units, and you can see we attacked it as two separate things. We converted one unit, and then we converted the other unit. There's a little page in my notes here that comes from your book that gives you just a strategy or a layout of how to attack these problems. You might want to read through this as it gives you a nice organized way of doing these problems, and that's what we're demonstrating here right now. Okay, before we do example 3, I want to talk to you a little bit about the third type of problem. Give you an example here. Let's say that I have a square, and this square is 20 square centimeters, but I want to convert it to the unit. I want to convert it to a different unit. I want to convert it to meters, or let's convert to millimeters. I want to know how many square millimeters is this area. Now, this is the third type of unit conversion. This is a unit conversion that involves a unit that is to a higher power than 1, so squared or cubed or to the 4th or 5th, whatever it is. And this is how we would attack this problem. We would start with 20 centimeters squared, and we want to get to millimeters. So we're going to have millimeters over centimeters. And that unit conversion for millimeters over centimeters would be that there are, now centi is 100 and milli is 1,000. So there's going to be 10 millimeters in every 1 centimeter. But this doesn't work because we're only canceling out 1 centimeter with the centimeters squared there. So what we're going to do is we're going to take that unit conversion and we're going to square it. And what's going to happen with that, if we have millimeters, just as an example here, 10 millimeters over a centimeter, the quantity squared, we square everything. So we're going to have 10 squared, millimeters squared, centimeters squared. And then when we type this into our calculator, we're going to end up getting 20 times 10 squared. We really could do this without a calculator, but that's fine. Now the centimeters squared is going to cancel out with centimeters squared, and we'll get millimeters squared. So this is 2,000 square millimeters of area. Okay, so that's the third type. Running out of time here, so I'm going to pause this video and you'll go on to the next video to finish this up.